Everyone, I would like to kindly welcome you because today we managed to gather at the Metaverse One. I know it's online, but I would like to kindly say hello from my home office interior. So today I will have possibility to tell you something about supercharging your Canvas apps, but from the perspective of optimization. So we will look at the performance and what are the common mistakes that developers and citizen developers often made and how to approach them. So I am Power Apps consultant at Cheat Team. And if you would like to, here is a QR code that you can scan. It will go to the Hey Link Me page when you will have plenty of my social media accounts like LinkedIn, like Instagram private and that a little bit more official, let's say. So this is from interaction perspective. So what we will talk today about. So today we'll cover few of those performance pitfalls and good practices that we should cover in our Canvas apps. So at the beginning, we will answer why actually we should create high performant application. Then we will go to OnStart, OnVisible start screen properties, metadata of our Canvas apps. Then we will navigate the comparison of variables available for us. We go through plenty of things. So I believe it would be much better to just start one after another rather than tell you each and every one of those numeric points here. So I deeply believe you already know why we should create highly performant application. And this is actually quite interesting topic because this highly performant applications ensures that our end user, so most likely our customers, sometimes it can be our colleagues from the company, but for consultants, it will be end user, so a customer, so that they have a seamless user experience, that they are not waiting a lot for data, so the loading times are optimum. So therefore, the functionality also is a top notch, right? So it enhances our end users' productivity and satisfaction. And we want to be sure that our customer or our colleagues are really happy with application that they are utilizing because they would like to have a little bit more from us. I believe this is a good scenario. And on top, if we will provide all of the performance topics that we'll cover today, the application also will be a little bit easier for our colleagues or even ourselves for support. It will be easier, scalable, and maintainable. So we will lower operational costs, which is also really important from business perspective. So, as we already know why to go with the performance approach and how, let's go with optimization stuff. So we will start with OnStart property, Unvisible property, and Start Screen property. This is something that we should cover because it is common that it's misleading and we are utilizing it wrong. So let's start where we can start this OnStart property. When we open our Canvas apps, under the metadata tab. So you have to select application tab and then at the drop down above, we can navigate to OnStart property. This property is responsible for executing code when application is being opened. So whenever you open your application as a user or as a developer, always this OnStart code that we put is being executed. Always it is the case. So the question is it good that it's always executed? What do you think? I deeply believe you already know the answer because it can slow your application. If we will put a lot of code over there, and for more complex scenarios of application, this is mostly the case. We, as developers, put a lot of stuff over there. We just want to have some data, some collections. We want to define some stuff at the beginning, and then the user is waiting and waiting and waiting. And what do they see? They just see a loading application. They don't see the app. They see the Canvas app Designer Studio that was designed by Microsoft, and they see that loading spinner only is over there. So we have to find a solution, what to do not to go with this slow opening approach. We don't want our users get mad. So what is happening when user is getting annoyed with our application? Then it's unhappy customer. They might not ask us for more applications. They might not want to use our applications. Okay, they might go with a different vendor, and we wouldn't like that. We would like to do good stuff so everyone is happy and we can do more stuff. Especially it's Canvas app. We love it, right? Okay, so where we should start? We should think about if we really need OnStart, because even Microsoft says, is it a good idea to go with up on start screen, on start property, right? We have alternatives. So let's go with the alternatives that we can use. So the main question is, if there is alternative, what is it? It is start screen property. This is OnVisible property, and also our good friend named formulas, which we will cover a little bit in detail later. So what actually is start screen and where we can find it? Start screen is also available to us through Canvas app's metadata. But this time, in this fancy dropdown we have at the top, we just select start screen. So what start screen is responsible for? We determine which screen should open first. So whenever our application will load, what will be the first screen our user will see? Which screen will open? So this is really crucial for us, and it helps us just a little bit, because then we can say, oh, we want to go there or there, depending if we have any parameters. But is it flawless? No, it's not, unfortunately. We have to use it really carefully, because as you can see, as example currently provided to you, we cannot use global variables. They are not allowed on the start screen. So our application can load global variables on start time, wherever the application is being opened, but cannot decide which screen should be opened based on those. It's a little bit painful, and we should find a workaround for it, because we can. And we'll talk about it in a second, because next point on our list is OnVisible. So OnVisible is actually now available for each screen that we have in Canvas apps, each screen that we will provide. So to go over there, you have to select the screen, for example, home screen, and then go to the metadata of that particular screen via the same dropdown. So what happens on this OnVisible? It's quite similar to OnStart property, because OnStart loads data every time the application will open, but application will open most likely once, right? Before we close it. But OnVisible is assigned to a screen, so we can access one screen plenty of times. So this code will be executed every time particular screen is opened. So if we'll navigate back and forth, then our code will be executed how many times we will open this particular screen. Is it good? Is it bad? Actually, it's difficult to say, because we as developers, as citizen developers, we have to decide, is it actually good or is it bad? Because I believe if we know that it's being executed always, then we can make some moves about it. But you have to bear in mind that it is for each screen you have in your Canvas apps, and it is executed every time you open each screen. You might put nothing over there, and that's completely fine. So let me show you and tell you what we should do and how we should use our available tools to get away from this OnStart property, and also how we can change our life not utilizing start screen. So of course, we can always put something on the start screen, but the answer to all our issues while opening the application is custom loading screen. So Why would we need custom loading screen? As we said, what is important is user satisfaction, our customer satisfaction. So if we won't put anything on start, then our application will open really quickly. Then straight away, we will open the first screen we want to show to the user, loading screen, which we can create as we want. We can create custom UI and custom user experience as our advantage. So we can put some company logos over there, branding templates. So our user knows what application they open, they know where they've opened it, right? And they are more keen to work with it. So they are getting a little bit more into the branding of their employee. So this is also really important. And if we'll have such a screen, and here is example how that screen can look like. And this is the simplest scenario. I've just created a PowerPoint slide. I've created a screenshot, uploaded it to the Power Apps, audit, loading spinner, some text, and voila. Of course, it's not perfect, but I achieved that in less than a minute. But if we are utilizing a custom loading screen, we have to make sure it's visible for the user for longer period than 1 or 2 seconds. We don't want it just to blink and go away. So the user have to see what's here. So they have to be there for at least 3 seconds. And then we can utilize OnVisible property to get data that we want to get from the beginning. So once again, what are the advantages? We get rid of the loading time of the application. It loads really, really quickly. We don't work with variables or anything like this on our start screen property. We just want to open this loading screen. And on this loading screen, only our imaginary is the limit because we can brand it with customer logos. We can create some checking logic of permissions, where we are, who logged in, what they want to do. Maybe application received some external parameter from the URL, and we want to analyze it. Is it from ongoing incident? Is it from the closed incident? Maybe user have special permissions to edit only some fields, and we need to navigate that person to particular other screen of our application. So user A goes to screen XYZ and user B goes to screen ABC. And this is a great example because everything here can happen in the background with quick loading time of the application. Okay, so next, something that we also have to be really careful is how we use variables. And those variables are split into few sections. So you have local, global, and temporary variables available for us. So what we need to do is actually to understand the difference between them. We need to know when to use which. Okay, so let's go through those variables. So here you see the table that is explaining everything. We have a global variable, which is available across all application screens. What does it mean? It is available everywhere, always from each screen. It is ready to use. And we'll go to how to declare those later. Next one, we have local variable. Local variable is available only in a single screen. We can, and I will show you how to achieve it, pass that variable, local variable between screens. So it actually, we can say, will live between two different screens. And then we have something called, by some people, one-time variable. I call it temporary variable. So this is a variable existing only in the function that we are utilizing it. Okay, so let's go to the details. So now, global variable. Here you got the example about how we are declaring variables. So for the global variable, we use function set. And here I know it is not about good practices on something like this, or but it is good practice to understand which variable is global and which variable is local and temporary. So we should add a different prefix at the beginning. So for global variables, it is commonly used to use GL and then underscore, maybe not underscore. It all depends on with whom you work to and what rules you have in your team. But GL is from global. So then inside your app, you can easily understand, oh, this is available everywhere. So the second part of the code is grab me a manager from Office 365 tenant of user that is locked to the application. Assign it to the global variable available all over the application. Okay, so it is stored with internal application memory, in internal memory of our application. So is it good or is it bad? It all depends on the use case. There are some variables that we would like to have available everywhere, but you have to make sure that you update that variable really carefully, because if it's being utilized in plenty of places, then wrong update can cause an issue and the rest of the app can fail. Okay, but as is it stored in internal memory of application, if we'll have plenty of those variables, they unfortunately might get a little bit, they can become a bottleneck. Our application have to store too much in a certain point. Of course, this is theoretical example, but we should know that if we don't have to, we shouldn't use it. So for those scenarios, we have local variables. Maybe we just need that manager to be visible in one screen. Okay, it's just one screen. Whenever you go out of the screen, it's not existing anymore for us. Okay, so it is not available everywhere. It's just one place. And this one place is the whole screen, so you can access it through plenty of labels or plenty of functions that you will write. Okay, so this is the same variable, the same end value, but created for a local variable. So you created via update context function. As you can see, it's totally different. Okay, so it is much lighter from the perspective of performance because it doesn't have to be stored always for the long period of time. And this longer period of time is as long as users will use our application. Okay, so how can we provide this application, this variable to be on different screen? How we can say, hey, go from this screen to another, but with this application. So when you will be doing a navigate function, which is telling our application that on certain action, go to the next screen, then you can provide in those fancy brackets your variable. And it then will be also available to you on the screen that you are navigating to. And this is also really good because it's easy for our application. Of course, if we need it on two screens, if we would need this or 3 or 4, then it's really worth considering getting back to this global variable. The next one, temporary. And this is one of my favorite variables, and I use it a lot. I use it, to be honest, all the time. But what temporary variable actually does, how does it live? It doesn't live in the perspective of a memory. It lives in the perspective of particular function, only when that function is being executed. So you utilize function with to use it. In those fancy brackets, you do quite similar logic as you do with the local variables. You provide the name, you provide the, and then what do you want to do there? After all, you go with comma, and then where you need that, what do you want to do with it? So for example, this particular code can be utilized within a label. So we want to request approval of time off, and we want to show our user to whom that approval will be sent to. So we can utilize this temporary variable to be inside of a label displaying a whole text to a user. So you can interpolate the string, and that will say approval sent to, and then the metadata of that variable. But we cannot reference to it from a different places of our application. So it's not stored in our memory like previous variables. And after that execution, it will be cleared from our memory. And what is really, really cool, you can nest with function. So rather than providing this approval sent to, well, where is it? Here. Approval sent to, okay. Then we can create a new with function that, for example, we will just get the display name. It's just theoretical example, but we can get into the metadata, or we can look for different stuff from this manager inside our tenant. So we can do a lot of stuff with that. And then it will just be gone. We don't have to think about it. It just will be gone. It will just live inside this scope. I love it. And I really encourage you to dive deeper about temporary variables and start utilizing it. From the naming convention perspective, we had GL for global, loc for local, and here it's the biggest issue if you will think from global perspective. I personally and my team utilize _v _. But I also heard that people are utilizing temp at the beginning or temp _, and this is great, but you have to be aligned with your team. You have to know how to look for those variables. And temporary variables are not available for us from the variables center in Canvas apps. So you can now keep track of those. Okay, you cannot see where those were created initially. So let's go to the next topic on our agenda. That would be cross-screen reference. Let me just take a little bit of tea. Okay, so why we should cover cross-screen reference? And I think it's really important to cover that while we are talking about variables, because variables are available to us on one screen or within a function or with all application. And we have to know if we need to use it everywhere or not. Is it only living in one screen? Same is with our labels, with the data on particular screen. The controls that we are utilizing. So cross-reference is when you use a reference to a control of a different screen. It's hard to explain it a little bit easier, but in different words. Let's create an example. The manager property that we had was displayed in a label on screen ABC. And screen reference would be when we would go on screen XYZ and we would like to show the same value, but rather to take that from one of our variables, global, local, or maybe do it again with temporary variable, then we actually say, hey, go to the previous screen, take that particular label when that was displayed, and provide me the text of it. So it will look like this. We have a speakers screen, right? Speakers screen. And on speakers, we would see that the name of the speaker is my name. It's Chris. Okay. And then we go to the cross-reference screen. So we navigate back to the right side, and our value is actually not from variable. It is from the label that is represented on this screen, on the first screen, on speaker screen. So what does it do for our performance? It's being actually said that if you do cross-screen reference, that the previous screen is being stored in the memory. Is it good? Is it bad? If you have really light performance screen, like this on example, when you have just two labels, then it's not a biggie. Okay, it's not a big thing. We don't have to worry about it that much. But imagine that you will create quite complex application, and you will have hundreds of controls. You will have few really complex galleries, headers, and it will be just a complex app. Then if you will go and reference that label, your previous screen will be all the time stored in the memory, like it would be open. So it would act like you have at least two open screens at the same time. It's really bad from the performance because it's really tough from the efficiency from our browser perspective. And it's even worse if you're utilizing a mobile device like a phone or tablet because they've got a different memory assigned performance approach, okay? So be sure that whenever you copy stuff, because this mistake is most likely done whenever you are copying stuff, that you can use variables. You can provide local variable to the next screen or just use global rather than copy and create some references between. Okay, it is really important. Look what you copy between screens. Okay, so from here, let's go to named formulas. This is really exciting. And I need to tell you that named formulas are cool. I hope you've heard about named formulas. So what actually is a named formula? Maybe I should start with this approach. So what is named formula? Named formula is a variable, we can call it a variable that has no execution dependency, it has no timing dependency. So it is being available to us whenever we need it. And on top of that, it is always up to date. Unfortunately, we cannot update it as we would like to within the comparison of regular variable. So you have a regular variable, you have to provide an action when you create that variable. That can be OnVisible. That can be whenever your user press a button. Then you do initialization of your data, of your variable. But for named formula, they will be available whenever they are needed. So your user doesn't need to doesn't need to click that button. Okay, so it's a little bit easier. And it is great because we can treat it as single source of truth. It will be also much easier for your team to support that kind of application later, okay? So they would just go to the formula section. And where is formula section? Formula section is available to us through application metadata. So you once again in your Canvas app select that app information, and then from the drop-down you select formulas. Yes, it is exactly the same place where you are having those information we were working on before. So start screen. So on start property, right? This is here. So what you have to bear in mind that there is a single place in the whole Canvas app to store named formulas. And you have to remember that after each formula written, you have to use the semicolon at the end. This is not the case whenever you are utilizing, creating variables, writing regular code in Canvas app. But for formulas, you have to do this. Otherwise, it will throw you an error. What variables you can create in formulas? You can create a regular, let's call it single property variable. So like color, like the previous one, like we created, okay? So like a manager name. Then we can create a little bit complex scenarios. So we get our user, we assign name and the full name. So we can have a little bit more complex scenario when you refer to the metadata after dot. You can create tables, you can create a lot of fun stuff, but you have to remember, you cannot change it on any action, okay? The definition is immutable. And it's really important, but if we'll create a table that will represent the data we want to provide in combo box or in dropdown, as long as user will not open the screen or a pop-up that will have that particular combo box / dropdown visible to the user, it will not load the data from the named formula. So that dropdown will not have any items, but it will not throw an error. As long as it's not needed, the data will not load. So we don't have to worry to load that data. The application cares itself when that data is being needed. And it's single place, so it's single source of truth if you want to change or fix something. If you utilize something plenty of times, then it's really good to create that reusable one item as a formula. Okay, so once again, let's review why named formulas are so cool. They do not delay application start time because they are not loading when the application is loading. They are loaded whenever they are needed. So they are really light to perform. They are stored whenever in a completely different way than the collections. They are really easy to optimize because we have only one place of definition. So you, as a developer or as a support engineer, you can go to formulas and see what's over there. It's really easy. It's really easy to find where they are being utilized. So one change and it will update everywhere. Okay? And the next cool stuff, order of initialization does not matter. So you can create first a color definition and then a border of a drop-down definition that will refer to the first color, and no mistake will be on our side because you can switch the order of it. It will actually understand and will take whatever they need first to, to the second value that we need. So they can reference each other, and it's a bless because you don't have to care, oh, that needs to be first, that will be second, and the order is crazy. And while we are talking about orders of variables, which is greatly solved in named formulas, we'll go to the concurrent section. So we will cover how, by default, Canvas apps are calling the data. So, quick break. Canvas apps, by default, are not calling initialization or calling the data at the same time. We need to utilize concurrent function. This function allows us to execute few things at the same time. But let's go to details. The normal way of Canvas apps works that the normal way is sequential load, so one after another. And if we are talking about performance, one after another, it's not a big deal, right? User have to wait. 1, 2, 3, boom. Then we have something, okay. And if there is an error, oh God, okay. We might not have what we want. So from performance, simultaneous. So at the same time is much better. So how does it look? So from scratch once again, if we want to get two different data sets and some variables, and then the third data set, this is how it will look from out of the box functionality. Okay, so we get one data set, second, then the variable, then the third, and the load time, as you can imagine, is first, second, third, fourth. It's a long way to go. Okay, I know we are in the cloud. I know everyone got a good Wi-Fi, but still, unfortunately, it's a little bit longer that sometimes users wants to work. So we can go from the sequential load into one after another, utilizing this concurrent functionality. So it will look like this. It will actually call from that data sets at the same time. So is it better? It is, but we have to be careful with that also, because we cannot we can proceed multiple actions at the same time, but we cannot work at the same data source or within the same variable or with the same collection, okay, within the same concurrent. So if we get that data from one data source and we want to do something else with it, first we have to get it and then we can work on it. We cannot do something that might influence the previous call. If they are executed at the same time, we cannot provide any functions or any data from the same data source because it can collapse within the execution. Okay, so this is a limitation. If we are aware of it, it will be a little bit easier. So how does it look from the code perspective? On the left side, you got out of the box. So the usual, as most of us are doing or were doing. So we get our manager approach example, okay? So we get global variable, we call for the manager, and then we're taking some data source. So we do one after another. So you get manager, you call Within the connector, you wait for the response, you save it to the variable, and whenever that is finished, we proceed. Okay, can it then be quicker? The right side is our guy, the concurrent. This is the guy. So we split it into the threads. So we say, okay, you have to do this at the same time. Just write this concurrent function and put inside whatever you need. And then how many those you will have, the many threads you'll have. So this is great, easy. But you can ask me a question, and that would be a valid question. How quicker is it if we're getting plenty of things at the same time? Isn't that if you're multitasking, you're getting slower? It is true. If you're calling for a lot of stuff at the same time, the response time of for all will be a little bit longer than if you would compare performance to each call individually. But the issue with each call individually is it is one after another. So you take that quick response, you put the next quick response, and then maybe you've got already two, so maybe it get a little bit stuck somewhere. So you get three that will be a little bit longer, and fourth also quite quick, but it will go on our axis quite far. And if we'll use concurrent, maybe they will be a little bit more extensive from response time perspective, but executed at the same time. So the response time for end user at the end will be quicker from concurrent perspective. So what are the benefits on the concurrent? They are your users get the data quicker. They don't wait that much. Okay, we can get the data on demand and provide it a little bit quicker. So the loading times are lower. How we can check that? This example that you had here, I have to be honest, it is straight from the Microsoft documentation. I didn't want to create it by myself because this example is great and they did it for us. So we can just use it as a perfect scenario. But to do this by ourselves, if you want to dig deeper into this performance approach, you can use a traffic monitor a network traffic monitor from your browser. This is one thing. So you can see from the developer tools perspective, what is happening from the networking perspective. And you will see the responses time also and what is being executed. Or you can do this through Power Apps Monitor to test this performance differences. From the Power Apps Monitor perspective, it's a little bit different because it shows you from the Power Apps perspective, the data that Power Apps are working, and from the developer tools perspective on the browser, you'll see much more data, and you have to filter what data actually you need. So it's more complicated scenario. So if we are talking about getting the data, how important it is to get the data, let's go to storing the data in our memory. So I'll call it Chase case. Actually, I'm not 100% sure how I'm supposed to pronounce it, but the deal is simple. We have to be sure that we store frequently used data in our application. We spoke about variables, right? That we can get some data, we can get data source inside a table as a collection. We can use this variable to get manager and store it all over the application. It is available for us. But the question that we need to answer, which data we really need to be inside our application, not to save trash to internal memory. Like I mentioned, our phones has different RAM possibilities than our PCs. If your end users will operate on Windows and will have 32 gigabytes of RAM, it's totally different than utilizing Android phone that is already 3 or 4 years old, because this phone can be passed from employee to employee after another by some hierarchy. I don't go into the details, but you can have different devices on end users. So we have to take care that those on different device types, the performance will be good. I'm not even mentioning, because it is not, unfortunately, the topic of today's session, the the responsive design, but it's also really crucial that we understand that this performance is available through different end users for formats, the different devices. Okay, so we have to decide which we want to store and limit the data. So first thing is to understand what data do we need, but then what we can do, we can limit the data even more. If we are talking about data source, let's use filter to get many rows of the data that we need. But we maybe just need 10 rows out of 1,000 available. Let's filter them, just take 10. If you want to work on a single row from our data tables, from the data source, use lookup function, just take a single row. Of course, you can create the same filters from the same filter from lookup perspective in filter perspective, and use first function to just get the one first record that you will receive. From the performance perspective, I've heard that it used to be, but it's not anymore. The question which one is more performant between filter and lookup. So you can use depending on the use case and how much you like the particular function. So if we can limit rows to our needs, we can also limit columns. And we have two functions in Canvas apps available for that purpose. So it will be show columns. So you decided which columns you want to keep, because maybe you just want to keep 3 columns out of 20 because you only need those 3. And the opposite is drop columns. So you have 20 columns and you want to get rid of 5 because 15 is what you need. So it's quicker for you as developer to say, I don't need those 5. Put them to trash. We don't need it. Don't store them, okay? Rather than provide 15 columns that you need, because you have to be aligned properly with the column names from the data source perspective. And it can be difficult sometimes. I'm not saying it's really difficult task, but I'm saying it's easy to get lost. You have to look there, here, maybe the display name is different. Sometimes different data sources act different. So be careful with those, but limit the data to your needs, because data stored in our memory can be accessed really quickly. If we will compare that to a call for the data, it's much quicker, okay? A connector call from our example, get manager. You have to get connector, you have to provide a query. You have to send the query to the data to the server. We need to get the response. We have to analyze the response. We have to save it somewhere. So if we will do this once, and then it will be available, of course, if needed, that's great. User, don't wait. You have it over there. That can be anything you want. Just think that through, and it will be quick because it will be there for you. Yeah, I think that was part of Friends theme song, right? Okay, so reusable code and reusable user interface. This is perfect, right? We covered so many examples and we just have few more to take, but it will be quick. Okay, so reusable code and reusable user interface. Why we should do this? Why we should create reusable code, reusable interface, or actually, is it something like this available for us? It is. It is. And in the slide, it should be a little bit differently because what we can use for this reusable code are components, are named formulas, and something called user-defined functions, which is based on named formulas. Okay. So let's start with components. As we go into the details previously with OnStart, Unvisible, variables, etc., due to that session is approximately 1 hour long, we'll not deep dive into components or user-defined functions. We'll just mention them, okay? So it is the quickest one of the quickest part of this presentation of this session. So if you don't know components are reusable building blocks available for us as developers, as citizen developers, inside Canvas apps. So we as makers can create those custom controls inside our application and utilize it all over our app. Okay, we can even go a step further. We can create something that is called component library. So we can create those reusable blocks that will be available for plenty of different applications. Okay, so we can create our own reusable blocks, and those blocks can be UI blocks. So we can create a label like header, like footer, okay, and reuse it. Create once, reuse plenty of times. But this is custom build. So we can utilize containers to make it responsive. We can add galleries to provide data into more automatic manner from visual perspective. We can write our own logic. Just don't forget the data source and it will be great. Or if you don't need a data source, that's also cool. So once again, why we should use components? They are reusable, once created, available through all application, all different screens. They are really performant efficient. They have custom responsive capabilities. Custom because we need to take care that they are actually responsive. Okay, that's a little bit not good. But if you don't need it to be responsive, just don't make it. You'll save time. It's based on the requirements, okay. They can access the scope of the application, but they don't need to. So I will also show you that this point is really crucial. And from the logic perspective, you can have custom properties, input, output, and trigger functions, events. So they are powerhouse of reusable items. And reusable items, I already mentioned header. From non-reusable approach, how would we create headers? We'd create, let's assume our application have 10 screens. You need header on 8 of those. Okay, so you create exactly the same UI from your blocks, from your controls with labels, back icon, some your picture, for example, on the top, right? Like a regular header. And then you copy it and paste into a different screens 8 times, as in example. And then the customer said, let's change something over there. Let's make a change. And you're screwed because you have to change each one by one after another, and it's not performant for resources perspective. You just have to sit there and do this awful job. You can create one component and add it 10 times. So if you need to do a change, you do a change once and it's applicable everywhere. And from performance perspective, not your time perspective as a developer, as a maker, okay, from performance perspective, they have totally different times of loading. They load a little bit differently than regular variables. But if you make it once, it will be initialized once, and it will just live through the life cycle of its needs. Okay, so if we know we can provide a property over there, it's all that we need to do for the header, right? Just provide the name of the screen we are over there, or of the application or selected item. Boom, it's there, and it doesn't have to take that much memory as creation of 8 or maybe 10 same visuals on different screens. And you will spend time once. You will do this only once. So if you want the component to access the data on the settings, you will have this small toggle. Be sure it's turned on if you want to use named formulas inside. Yes, they are available. If you want to use collections, tables, variables, whatever data you will get or create, it will not be available if that toggle is not on. So bear that in mind. And let's switch to examples of those components. Header, we already talked about. Footer, I don't think it's that frequently used, but for more complex application, we might have the confirmation box. So you want to do, hey, dear user, you selected delete this item. Are you sure you want to delete this item? And if you would have to do this confirmation on 10 different galleries, so probably 10 different data sources, you could create one confirmation box, one UI block. It might be a pop-up, okay? And that's it. Just put the logic over there. If this is this one and the user data source one, and if the user will say confirm, I want to delete, just delete from this data source. That easy. So one place taking all the logic, and you don't have to recreate that from visual perspective. Sidebars, regular navigations, pop-ups, this is the great example of the whole components because they provide UI blocks. But named formulas, again, they are reusable, but from a different perspective because this is actually data reusability. We can also use collections as a data reusability, but formulas would be more efficient for those drop downs, something like this. So here is, once again, if you joined a little bit later, if you're not with us since the beginning, here's once again definition of named formulas. I will just say one thing to remember for everyone. They are always available when they are needed to be, and their definition is immutable. Okay, they are always up to date. Next, so within those named formulas, we have user-defined functions. So if you will see that online, they are also referred as UDF as a shortcut. So what they are, first of all, they are not available for us out of the box. Okay, we need to put that on. For now, the last time I've checked, and that was 2 weeks ago, they were still in experimental mode. So we just need to put that on. Be sure that you know that you are utilizing experimental feature, maybe not good case for the production app. Okay. So what you can do, you can provide a code formula to calculate something for you. This is example of multiplying numbers, and it is being done in the same place as you create formulas. Up formulas from the dropdown, you will have all the data that you've created previously here, okay? And user-defined function will be provided whenever you want it to be. This example is a common example from Microsoft documentation, how you can use them. We can create our cells and examples, but I'll give you a heads up. I wanted to create a custom error log of what's not going well in the application. So what errors the user received, like a network error. And it turned out that within the user-defined functions, I cannot influence a data source. So I cannot provide data to the data source, which is a shame. Because every time I find an error that is handled, I can do, if that error occurs and we know it's here, we can actually save it to the data source. Let's be sure what's going wrong so I can make better applications in the future. No, I cannot execute user-defined functions to create error log, but I can calculate numbers, I can calculate dates, I can calculate the time between dates. So this is what's available for us. It's really powerful, but I believe the functions available in components are more powerful, but they are different. Okay, last 2 points. The quickest point ever. I'm telling you that. So the Canvas app settings. Be sure what features currently are available. Microsoft changes stuff with releases. So whenever there is a release, you can go over there to your Canvas app settings and see what is there. You can write a description, you can go to the documentation and decide what you would like to use in your application. So it will be good for you. For example, delay load. I deeply believe it's a little bit better for the user. It's better for the user to see loading circle loading spinner for in their application for half a second till the data will get there, then create overloaded from the memory perspective application that will be laggy and that will be buggy. Yes. And I don't keep recently visited screens in memory because this is a cross-reference approach. Why I should keep it over there if I can just load it again? Okay, user will wait for that loading time. But still, small loading time is still better than buggy. It all depends on how big your application is, because you can say, yes, Chris, but you mentioned quicker means better. Yes, but we have to understand the scenario that we are working on. Not every scenario is the same. So here I've got a few takeaways for you. As recap of the whole session, reduce code on your application OnStart property. And to be honest, I wouldn't recommend to use it. Just create this custom loading screen. Make this so good that your customer or your colleagues from work will be happy to use it. Of course, with time they will get used to it, of course, but they will really enjoy it. The app opens quicker. You get the branding, you've got the look. It's powerful thing, to be honest, for end users. Then understand when you should use local and global variables. So one screen available and all app available. Or maybe you don't need any of those for particular scenario. You can use temporary variable. That's really, really powerful. I tell you, I use it all the time. Don't do cross-screen references. If you need the data on two screens, use local variable and pass it to a second screen, or use global variable. Then get the data concurrently, okay? If you can, take it at the same time. And you create reusable code. Limit the amount of data you take from the data source. And this is all. Please rate my session. We got 3 minutes till next session, so I took my time. I took my time. So please rate my session. And if you have any queries, we don't have much time currently, I'm sorry. Here is that QR code once again. So you can ask me via LinkedIn. You can send me that message. I'll make sure I'll accept you. I'll send you the response to your question. So please rate. And if you would like to not only ask something, follow me on LinkedIn. I add some tips and tricks also over there.